Hey everybody, and today I'm going to be showing you how to find both an arithmetic and geometric series, a finite arithmetic and geometric series. So we'll be starting with arithmetic here. So we have the sequence 9, 13, 7, 21, and 25. And we want to find if there were a finite number of these terms, what would it add up to? The first thing I want to do is make a general formula for this so that I can put it into summation notation. So I'll show that first. So the first term is, well, I'll just write it down as a, and this is the wrong brush, an equals 9, that's our first term, plus n minus 1, and our common difference is just 4. So we simplify this out, this becomes, let's see, minus 4, so that's 5 plus 4 n equals a n. So here we have the general term for arithmetic series. What we can do now is, since we're looking to sum up all the numbers, we bring in sigma or summation notation. So that's just the little Greek e. That's a really bad one. It would look a little something like that. And we'll say n equals 1 because we only have our first term. It starts at the first term. There's no 0th term. Let's say there's a large number. Let's say there's 200 terms in this series. 200. And then from here we can just plug in our general term, and that's what we have. So this is how you would say you would want to sum up a sequence starting at 9 and it goes to 200. So we would say the sum as n goes from 1 to 200 of 5 plus 4n would be, well, it'd be something, it'd be a large number. So we're trying to find out what 200, like if we had this sequence and it were to go on for 200 terms and we wanted to add up every number, that's what we'd have. So that's when we bring in this equation here. So we have x1, so our first term, plus xk, our last term, times k over 2, which is just the number of terms over 2. So, well, we know our first term, so we have 9 plus, now we don't know our 200th term, we'd have to plug that in. So 200 times 4 is 800, plus 5, that's 805. So 805, this equals 814, 814. And then we would multiply that, so we'll put this over 1 times 200, because that's how many terms we have, over 2. So we can actually simplify 200 over 2 out to 100 over 1, so we'll do that instead. That looks like a y, it's supposed to be a 4. There you go. Over 1 times 100, which is also over 1. And this is pretty easy, you just multiply it out, and that gets you 81,400. The 1, it's over 1, so it's just 81,400. So we would say the term, or rather the series, or the sum of this sequence as n goes from 1 to 200 of 5 plus 4n would be 81,400. Meaning, if we have our original sequence here of 9, 13, 17, 21, 25, and it were to go on for 200 terms, or rather 195 more numbers using the common difference, and we wanted to add up all those numbers, we would get our sum of 81,400. And this right here, the x1 plus xk times k over 2, is how you would find the series of a finite arithmetic series. If it were infinite, it would just diverge to positive or negative infinity because it never stops. So now, that's not what I wanted. So now I'll just get rid of this and we'll move on to the geometric series version of it. Alright, so let's say we have a geometric series of 3, 9, 27, that's really bad, 27, 81, and 243. So first thing I want to establish is the common ratio, and the way you do that is just you do any two consecutive terms with the second term on top of the first term in a fraction. So in this case it'd be 9/3, which obviously equals 3. So our common ratio, let's label that R, is 3. Next up, I want to put this one in summation notation as well. And in order to do that, you would have to find the, the general term for a geometric series, which I haven't shown that, but I'll just do that here. So that would look like A1, so we would have 3 as our first term, times R, which is 3, and then we'd raise it to the power of k minus 1. If you don't know what k is, I'll establish that in a little bit. This is our general geometric series equation. So now we can just put it into summation notation, meaning we want to add up all the numbers. We say n equals 1 because there's a first term, and we can say it goes from 1 to 10. Make this a little easier. Meaning that there are a total of 10 terms in the sequence. We have 5 listed out here. So now we want to find the sum of all those 10 terms. In order to do that, you would use the equation rated here. We'll do A1 times 1 minus r to the k over 1 minus r. So let's just plug in some values here. We know our first term, that's 3, times 1 minus r, our ratio, which is also 3, and k would be the total number of terms in the sequence, which in this case it's listed at the top here, it's 10. So 3 to the 10th. Oops. Over 1 minus 3. Now this is where you need a calculator, but I'll simplify a couple terms out first. So this would also be 3 times 1 minus 3 to the 10th over negative 2. So now let's just raise 3 to the 10th. Let's see. 3 to the 10th. So we'll do 1 minus 3 to the 10th. Gets you negative. So we'll write this here. 3 times negative 59,000. What is it? 48. 48. And you can see since there's two negatives, they'll cancel out and become positive. You won't have any weird numbers. So we have 29,000. Just ignore the negative. I didn't put a negative sign for the 2. 29,524. Now from here, now that we've solved out the parentheses, we can just multiply this by 3. So times 3. That gets us 88,572. Remember, just keep things positive, because it wouldn't make sense for this series to be negative. 572. So now we have our series for the a finite arithmetic series, which is, or sorry, geometric. So that's our sum here, and we would use this equation here to find the sum of it. In order to put anything in the summation notation, you just take the general term of whatever you're looking at and then plug in the numbers. So if we start at the first term and it would equal 1, if it goes on for 500 terms, the top number on top of the summation would be 500. This just represents how many terms there are in the sequence. This represents our starting term, like if we had a 0th term, it would be 0, but in this case we don't, just 1. So yeah, don't get scared. The little Greek E just means to add everything up. So yeah, thank you for watching.